everyone, we're Profi and we're gonna explain Newton's method. We use Newton's method for approximating zeros, and we can use it if you don't have a formula to solve an equation like x to the 5 minus 5x plus 3 equals 0. And the formula we use is xn equals xn minus 1 minus f of xn minus 1 over f prime of xn minus 1.
All right, so starting off, the first example is starting with x subscript 1 equals 2, find the third approximation, x3, to the solution of the equation x cubed minus 2x minus 5 equals 0. So the first step we're going to do here is we're going to find the derivative. xn minus xn to the third minus 2xn minus 5 over 3xn to the second minus 2. So as you can see, we took both equations, we put them over each other in this context, and then we added n's wherever there was x's so that we could continue on with the approximation process. All right, so then from here, we're just gonna essentially plug in the x subscript 1 equals 2 into the equation. So we start off, xn plus 1 becomes x2, then x1 minus, we have 2 cubed minus 2 times 2 minus 5. Then we have 2 squared minus 2. Then from here, we're going to continue and solve. X1 we have as 2, so then 2 minus 8 minus 4 minus 5 over 2 to the second, which would then become 12 minus 2. So then here, once we solve this out, we would get 2 minus -1 over 10, which then becomes 2.1. So that's going to be our first approximation. All right, so now essentially we're just going to take the approximation we did for the x subscript 2 and use that and plug it into x subscript 3 into the Newton's method. So we're going to use Newton's method now and take x subscript 3 equals to x subscript 2 minus, we're going to do x subscript 2 cubed minus 2x subscript 2 minus 5 over 3x subscript 2 power of 2 minus 2. So then here, now that we have this equation, we're going to plug in 2.1 wherever we see x subscript 2. So we'll take x subscript 3 equals 2.1 minus 2.1 cubed minus 2.1 minus 5 over 2.1 squared minus 2. So now, once we solve this out, we get x3 equals 2.1 minus 9.2 minus 4.2 minus 5 over 12.6 minus 3. And then once we work this out, 9.2 minus 4.2 minus 5 is just about 0. So 0 over 9.6. So when you subtract 0 over 9.6 minus 2.1, you get 2.1 again. So since x subscript 3 is 2.1 and approximately 2.1, we know that this approximation of 2.1 is the most accurate one for this equation. Normally, using Newton's method, you would make sure it was accurate to 8 decimal points. That's just generally how Newton did it. But in this equation, it asks for the third approximation, so we're stopping here. Also, something important to note about this equation, the reason they chose x subscript 1 equals 2 is because Newton did this problem, and this was the equation he began with. So there you have it, example 1.
Okay, so for the second problem, we are going to use Newton's method to find the 6th root of 2 correct to 8 decimal places. The first thing that we're going to do is we're going to take the 6th root of 2 and we're going to equal it to x. So now what we're trying to do is we're trying to get this equation to equal 0. So we have to move everything to one side. We'd have to take x to the 6th power in order to eliminate the radical. So then it would just be 2 is equal to x to the 6th. And then in order to get this to 0, we'd have to bring 2 to the other side and get 0 is equal to x6 minus 2. So this is what would be our f of x. So we can write this down here. And then we also need, for Newton's method, we need f prime of x. So we can just solve for f prime of x here and have the first derivative of this would be 6x to the 5th power. So now the way that we can apply Newton's method to this problem would be x subscript of n minus x subscript of n to the power of 6 minus 2 over 6x subscript of n to the 5th power. So remember that this is the original function and then this is the first derivative. So now that we have our first x value, we can now continue with x2. So that would be equal to 1, using this equation again, 1 minus negative 1 over 6 times 1 to the 5th power. So technically this would just be 1 minus negative 1 over 6, because 1 to the 5th power is still 1, and then 1 times 6 is equal to 6. And when you do this, you would get an answer of 1.166666667. So remember that the reason why we're using so many decimal places is because Newton's method is typically used up until the 8th decimal place. So throughout the whole problem, we're going to be going to the 8th decimal place. Now that we have this answer, we are able to do x to the 3rd, which would then be this number over here, so 1.166666667 minus, and then once again, just get this big number over here. Put it to the 6th power, subtracted by 2, over 6 times the big number. So once again, when you do this math, you will get an answer of 1.1264438. Now that we have our answer for x subscript of 3, we can now once again continue to x subscript of 4. So you're going to get this big decimal and once again restart our equation. So once again, we're putting that big number to the 6th power and then subtracting that by 2. And then for the bottom, we are going to get 6 times that big number to the 5th power. We are going to get an answer of 1.122 49707. So because our two numbers still aren't similar, we're going to have to keep going. So x subscript of 5, and then this is going to be the big number that we got over there once again. So it would be 1.122499707 minus, going to go into a fraction, set that to the 6th power, subtract that by 2. And then in the denominator, oh, my bad, I forgot the little 6 here. But yeah, so when you do this math, you're going to get an answer of 1.12246,205. So we're starting to notice that our two answers are starting to get closer, but still they're not quite as close as we want them to be. So we're going to try it one more time to see if we can get it even closer than before. So we're going to take, once again, our big decimal. So it'd be 1.12246,205 minus the decimal to the 6th power, subtracted by 2, over 6 times 1.12246,205. And when we do this math, you guys are going to realize that, to the 5th power, I'm sorry. We're going to realize that we actually get the same answer that we got over here. So when we get these two answers, we're going to be able to conclude that this is our final answer. So given Newton's method for this problem, we can conclude that the 6th root of 2 is 1.1224605. Thank you guys for watching, and if you have any comments, questions, or concerns, we're going to put our email up here and you guys can email us.